So welcome back to the Diatom Web Academy, organized by the Diatom Taxonomic Certification Committee of the Society for Freshwater Science and diatoms.org. Make sure you follow us on Facebook, Twitter, YouTube, and join our email list for the latest updates. Before today's webinar, I would like to share some links with you. Head and check out diatoms.org homepage, where you'll see each day in November, a new genus image will appear as the homepage banner. And you can see if you can identify those genera. Get ready to play. Also, I wanted to share on the practitioners section of diatoms.org. You can find the most recently published taxon pages, as well as useful resources like how to clean diatom samples and how to measure diatoms. So I'll share those links in the chat with you shortly. And I'll go ahead and introduce today's speaker. We're very excited to have Dr. Luisa Riato with us. She is an ORISE Fellow at the U.S. Environmental Protection Agency in Corvallis, Oregon. Previously, Luisa earned her doctoral degree from the University of Pretoria, and her research included developing diatom-based multimetric indices to assess wetland condition and acid mine drainage impacts in South Africa. So welcome, Luisa, and please go ahead.
Thank you, Sylvia, and thank you for inviting me to this seminar, and thanks everyone for joining. Let's pick this off to get through the slides, okay? So I'm going to talk about the project we're working on to develop trait-based diatom multimetric indices to assess rivers and streams across the conterminous US. So this project is a collaboration with some of the National Aquatic Resource Survey team, NRSA, at the US EPA's Office of Research and Development in Corvallis. And the team includes Alan Herlihy, Dave Peck, Phil Kaufman, John Stoddard, Steve Paulson, and also Ryan Hill, who's a researcher at the Office of Research and Development there. So just to give you some background about my work with diatoms. So before I started the postdoc at the EPA, I spent over a decade in Africa, and I was analysing diatom samples from all over the continent, including the Congo. And I came across many weird and wonderful diatoms that I was trying to ID to species level for aquatic assessments, but of course, many were undescribed species. When I started my PhD in South Africa, I had similar issues, struggling to identify species that had never been described. So to address those challenges, I started to look into the use of diatom traits for aquatic assessments, and can we assign traits using genus-level taxonomy instead of species level to provide just a simple and effective assessment? So today I'm going to talk about the use of genus-level taxonomy and diatom traits to develop diatom indicators for aquatic assessments with a focus on large-scale regional assessments. So most of you here may already know that the methods used to analyze diatoms for use in aquatic assessments is typically a species-based approach. So diatoms are analyzed to species level where possible, and then species abundances are used to indicate environmental conditions like pH and salinity and nutrients. But in large scale and or long-term programs in the US that use multiple analysts, multiple laboratories, there's issues with the diatom analysis practices that have caused inconsistent taxonomy among the different analysts and labs. And this has resulted in a lack of confidence in the data and has made the diatom data unreliable in large assessment programs like the National Rivers and Stream Assessment Survey, NRSA. So there are 4 analysis practices that have been identified as the cause of taxonomic inconsistencies among the different analysts and labs in the US. And this is taken from the Allers, Garcia, Lee, and Spalding paper that was published this year. So first is the use of European taxonomic books to identify North American species. So many North American diatoms are found in Europe. And so analysts in the US often use these European taxonomic books to ID species. But there are many North American diatoms that aren't in Europe, but still there's a tendency to use these European books to try to assign a name to a species. And that can lead to errors in the data set. And then also there's taxonomic resources that can vary among labs. So some labs might have a comprehensive set of taxonomic books, which are expensive. And then some labs might have limited resources to ID species. And so this can result in inconsistent taxonomy among different labs. And then also diatoms are a highly diverse group. And in the US, there are many undescribed or inadequately described species. And then finally, analyzing diatoms to species level requires a lot of effort and expertise. Because the analysis is time restricted, this can increase the chance of misidentifying species if the analysts are under pressure. And some of these issues are not just a problem in the US, but are an issue for many diatom assessment programs across the globe. So in Europe, for example, misidentification of diatom species is common. And so diatom traits are being increasingly used in European river and stream studies to address this issue. So diatom traits are based on morphological, functional, or physiological features. And then the presence and abundance of taxa with different traits can be strong indicators of environmental stressors, such as nutrient and organic pollution, turbidity and salinity. So to give you an example of the types of traits, so we have the Motile guild, and these are fast-moving diatoms, such as species of the Navicula genus shown here. And species that fall under the Motile guild are usually tolerant of disturbances such as eutrophication, organic pollution, high turbidity and salinity. And then we have diatoms of the high-profile guild. There are tall diatoms, such as species of the Gomphanema genus shown here. And these tend to be sensitive to disturbances such as high conductivity and turbidity. And then there's tube-living diatoms that move freely inside a mucus substance, such as species of the Frustulea genus often found in these tubes. And tube-living diatoms are generally sensitive to eutrophication and organic pollution. So you can use genus-level taxonomy to assign traits to diatoms. And the good thing about this is that genus taxonomy is relatively easier and quicker to analyze than species-level taxonomy, and probably less prone to taxonomic inconsistencies related to analysis practices, such as time constraints to complete the diatom identifications. And also the trait response is thought to be independent of ecoregions. And so traits could be used in different ecoregions that have very different diatom flora. And this could be an advantage because many of those undescribed taxa in the US are found within a specific region. So given that, we wanted to see if we could develop an effective diatom MMI based on genus-level taxonomy and trait information to assess rivers and streams across the US using the NRSA diatom data that could perhaps complement other existing NRSA MMIs. So to develop the MMIs, we used the 2008-2009 NRSA diatom data to develop candidate metrics by assigning traits developed by Passé and Remy and Boucher to taxa at the genus level. So some examples of trait assignments are shown in the table on the right here. So for example, you have the Gomphanema genus assigned to the high profile guild, Frustulea to the tube living life form. and so on. And we also used all the diatom genera to develop different candidate metrics. So we developed 3 separate MMIs based on 3 major climatic regions in the US. So that's the West, the Plains, and the East. And these were created from 9 NRSA analysis regions. So the West, which includes the Western Mountains and Zurich, the Plains, which is the Northern, Southern, and Temperate Plains, and the East, which includes the Northern and Southern Appalachians, the Coastal Plain, and the Upper Midwest. So each MMI was developed following similar methods used to build existing NRSA MMIs. So metrics are selected from a pool of candidate metrics based on having a wide range, having strong responsiveness. So that's a good ability to discriminate least disturbed sites. Those are reference sites that passed a series of stressor-related screens. From most disturbed sites, those are sites that are stressed. And then having good repeatability, so having a high signal to noise ratio. So that is a measure of the relative magnitude of among site variation versus within site variation. And then good sensitivity, so that's the ability of the MMI to identify sites as impacted from the pool of most disturbed sites. And then finally, having a low correlation among metrics. So from the final candidate metrics, we used an approach similar to Van Sickle's, where we calculated thousands of potential MMIs with combinations of 4, 5, 6, 8, or 10 metrics. And then we chose the best performing MMI based on their overall performance, such as limited redundancy among metrics and good repeatability and responsiveness. And then the best performing MMI for each region was validated using the 2013-2014 NRSA Diatom data. So here are results of one important performance measure that I mentioned. So that is the responsiveness of each MMI. So how well an MMI distinguishes least disturbed sites, that's the reference sites, from most disturbed sites, that's the stress sites. So here the box plots show the distribution of MMI scores for least disturbed sites, that's the box plots in grey, and then the most disturbed sites, that's the box plots in red, for the Plains MMI, the West MMI, and the East MMI. So the larger the separation between the grey and red box plots, the greater the ability of the MMI to discriminate least from most disturbed sites. And you can see that there's separation of box plots for each of the MMI, especially for the East MMI, which has the greatest separation of box plots. You can see the gap here. So overall, each MMI has good responsiveness, particularly the East MMI. And then looking at other MMI performance measures, all 3 MMIs have good signal to noise values shown here and low correlation among metrics. And then the East and West MMIs have good sensitivity, it's high percentage here. And the Plains MMI has a poorer sensitivity at 10%, although it's still within the range of other NRSA MMIs. So if we look at the Plains MMI in more detail, here are box plots showing the distribution of Plains MMI scores between the least and most disturbed sites within each of the Plains regions. And you can see that the Plains MMI is able to discriminate well in the temperate and southern plains, but not as well in the northern plains here, which could be because the least disturbed sites are widely distributed, because it's difficult to find reference sites that don't have some degree of disturbance in this area. So we wanted to make sure the MMIs work on a separate set of sites. So we tested the MMIs on the 2013-2014 NRSA Diatom data. So in each plot shown here is a comparison of the ability of the MMI to discriminate least from most disturbed sites based on the calibration data set. So that's the 2008-2009 data that the MMIs were built on. And the validation data set, that's the 2013-2014 NRSA data. So looking at the box plots based on the validation data, the East and the West performance is strong. In fact, the West MMI discriminates even better between the least and most disturbed sites of the validation data. You can see there's more separation between the validation box plots than the calibration box plots. And looking at the validation box plots for the Plains MMI up here, it still performs well. So overall, each regional MMI performs well on a different set of sites. So this is a table that shows the final set of metrics for each of the 3 MMIs, where each MMI has a set of 5 metrics that is a combination of trait metrics and genus metrics, which are either sensitive or tolerant to disturbances. So for example, in the East MMI, we have the tube living and high profile metrics that I showed in the videos earlier. And we would expect that these would be sensitive to disturbances. And also you can see that for all 3 MMIs for the East, the Plains and the West, we included a metric that combines both Achnanthidium and Achnanthes individuals. We found that by combining both genus, we got a better MMI performance than if we just had Achnanthidium, for example. And a practical advantage of combining the 2 genus is that Achnanthidium and Achnanthes species can look similar and are often hard to distinguish from each other. So it could be easier and quicker to analyze if you combine the 2 genus together in one metric. So just to recap, we assign traits to each diatom species using genus-level taxonomy, using the Remy and Boucher trait database. And in many cases, most species of a given genus have the same trait, but certain genus can have some level of trait diversity. So some species of a genus may have one type of trait, while other species of the same genus may have a different trait. So just to give you an example, many species of Fragillaria genus belong to the high profile guild, but there are some Fragillaria species that can belong to the planktonic guild, like the one pictured here. So could assigning traits or assigning taxa to traits at the genus level and not the species level introduce some sort of error that could significantly affect metric performance? So for each trait metric in the final MMIs, we wanted to see if taxa that had been assigned traits at the genus level had actually been assigned the correct trait at the species level, so we can determine whether these trait metrics are repeatable and robust. So if we look at the trait metrics in the Plains MMI, for example, we've got the tube living metric here and the M-fixer metric. And for those of you who don't know what M-fixer diatoms are, these are diatoms that have this atmospheric nitrogen fixing cyanobacteria and are found in low nutrient waters. And so this table shows the component genera for each of those metrics. So the tube living metric includes species of 6 different genera shown here. And the M-fixer includes species of the Epithemia and Rhopalodia. And as far as I understand from the literature, all species of Epithemia and Rhopalodia are M-fixing. So all species that have been assigned the M-fixer trait at the genus level had been assigned correctly at the species level. So what about the tube living metric? So this bar chart plots the percentage occurrence of each species across all the Plains sites that were included in the tube living metric calculations. So the species shown here are from the NRSA 2013-2014 sites, and they're present in more than 1% of sites. So the species in dark blue are tube living, and so these had been assigned correctly at the genus level. And then the 2 species in light blue were not in Remy and Boucher's database, so we still need to confirm if they were assigned correctly, but it's very possible that these 2 are also tube living, and it would be good to confirm that with the larger diatom community. And if they're not tube living, they have such a small occurrence, this error shouldn't affect the overall metric performance. And so it looks like the trait metric could be repeatable in the Plains MMI. And then we want to see if this tube living metric was repeatable on a state level diatom dataset from the Plains region. So using the state of Indiana diatom data, again, we look to see if taxa assigned to tube living at the genus level have been correctly assigned tube living at the species level. So this bar chart again plots the percentage occurrence of each species across all the Indiana sample sites that are included in the tube living metric. And you can see that the species in dark blue are tube living, and so these have been assigned correctly to this trait at the genus level. And then the species in light blue weren't in the trait database. So we still need to confirm if they were assigned correctly, but if they weren't, they have such a small occurrence that we can't see this being an issue for the overall metric performance. And when we looked at the other traits included in the East MMI and West MMI on a different set of sites using the NRSA 2013-2014 data, we found the same pattern of results, that except for 2 or 3 species, all species assigned traits at the genus level had been assigned the correct trait at the species level, which suggests that other trait metrics are also repeatable in the East and the West. So we checked if any of the metrics in the MMIs were associated with analyst bias related to taxonomic inconsistencies associated with the analyst practices. And so we used similar method to Sylvia Lee's et al. 2019 harmonization paper. So running a random forest with AnalystID as one of the variables, along with several NRSA environmental variables, to check if AnalystID was a top predictor for any of the metrics included in the MMIs. So AnalystID was actually a top predictor for the metric N-fixer in the Plains MMI, followed by nitrate, latitude, and longitude as the other top predictors. So it's important to note that N-fixers are typically found in waters that are low in nutrients, like I mentioned earlier. And the box plots on the left show the number of N-fixers identified in samples processed by the different analysts in the Plains. And the box plots on the right show the amount of nitrate associated with the samples processed by the same analysts. You can see the analysts 1 and 3 circled here had identified the most N-fixers of all the analysts. But if you look at their samples were associated with low concentrations of nitrate. And this is what we would expect because N-fixers prefer waters that are low in nutrients. Analysts 4 and 5 circled here had identified few N-fixers, but their samples were associated with higher concentrations of nitrate. So we would expect fewer N-fixers in their samples that are high in nutrients. And if we look at the location of the samples processed by the different analysts in the Plains shown in the map here, you can see that analysts 1 and 3, that's the red and green dots here, who had ID'd more N-fixers in samples associated with low nutrients. Their samples were located up here in this area up here. The analysts 4 and 5, that's the purple and orange dots, who'd ID'd few N-fixers in samples associated with higher nutrients. Their samples were located in a completely different area of the Plains in this area down here. So it looks like there's a distinct difference between the location of the samples and the amount of nutrients. And it's probably this environmental gradient that's causing these taxonomic differences, not because of analyst bias. So we kept the N-fixer metric in the MMI. And then the other metrics in the MMIs didn't have AnalystID as a top predictor. So here is a table showing how responsive our MMIs are compared to existing NRSA and National Lake Assessment MMIs, shown by the t-value between mean, least, and most disturbed sites. So you can see that the East MMI is the most responsive of all the NRSA NLA MMIs with a t-value of 18. And then the Plains MMI with a t-value of 9.6 is as responsive as the other MMIs for that region. And then the West MMI with a t-value of 8.5 is comparable to the stream fish and lake bug MMIs, performs a little better than the lake zooplankton MMI. So it looks like the Diatom MMIs are comparable with other NRSA NLA MMIs. So just to conclude, and I'd like to emphasize this, that we're not suggesting that our genus-level approach replaces species-based approaches, but instead to provide an approach that could be effective and reliable for large-scale and/or long-term assessment programs like NRSA that haven't been able to confidently include diatoms in their assessments because the data is unreliable. And it could also allow programs to revisit older diatom data sets and look at historical trends in freshwater condition. And it's likely that this approach is more immune to inconsistent taxonomy because it requires less taxonomical skills and is less labor intensive. It's quicker and easier to identify at genus level than species level. So there's going to be less errors and a more robust data set. And then from a financial point of view, this seems like a more cost-effective approach. And this might be attractive to states that have limited resources for species identification. And another advantage of using traits and genus metrics is that we keep the information of all the taxa in these metrics. So we're not losing any ecological information. So if a diatom can't be identified species level because it's undescribed, it doesn't matter in this approach. The species will still be included in these metrics as long as we can identify the genus. So these diatom MMIs could possibly complement existing NRSA MMIs, and perhaps these regional MMIs, or at least this approach, could be applied to state level data sets. And we're also interested to test this approach on other aquatic systems like lakes, where lake programs have had similar challenges with their diatom species data. With that, I will conclude and happily answer any of your questions. Thank you.
Thank you, Luisa. And I'd like to give folks a chance to ask questions. You can either raise your hand and ask your question, or you can put it in the chat. While people are getting their thoughts together, Luisa, I wanted to ask about Mularia. I noticed that you had Mularia as a tube-living genus. Where did you get that information?
I got that from Remy and Bushy's trait database, which I'm happy to share with you. Because in all honesty, I wasn't familiar with that genus, but according to their database, it fell under that particular trait.
Yeah, that's quite surprising to me to see that. Okay.
So can I ask you, Sarah, what trait do you believe that it belongs to then? No.
Oh, I've never seen Mularia in tubes, and that's been a genus that I've worked on quite a bit. There are only a couple of species in North America, but I don't know them to be tube dwelling. I don't know, it also is very rare, so I don't know that it would really make that big of a difference.
I can certainly check in with Frederick Remy and discuss that with him.
Okay, question in the chat, and then we'll go to Tom, who has his hand up. K. Fritz asks, does the Diatom MMI responsiveness vary with geographic position within the regions? Or do the ecoregional boundaries reflect diatom phytogeographical differences in metrics for the least disturbed sites? Maybe this is the second part of it. Could the regional boundaries be changed to optimize responsiveness of the MMI rather than only apply them to the current lumped ecoregion application.
Right. So the lumping, though, was on a massive scale. These are mega regions. So, for example, the East was the most responsive of all other regions, i.e., the West and the Plains. But these encompass huge areas. So they include a number of the NRSA analysis regions are broken down into 9 units. And so these mega regions are 3 large climatic regions that encompass those NRSA smaller regional units. So yeah, I did see a difference between the East, the West, and the Plains. But to change the boundaries, you mean perhaps make the scale even smaller? And that would be perhaps testing or developing an MMI for particular regions, let's say, for example, in the East. So I did that for the Plains MMI. I was trying to improve the responsiveness of the Plains MMI. So I developed separate MMIs for the Southern Plains, the Temperate Plains, and the Northern. And I actually found that in the end, the general Plains MMI performed just as well as the individual MMIs for the Southern Plains, the Northern Plains, and the Temperate Plains. And so for consistency, we wanted to just have 3 large regional MMIs if the Plains MMI wasn't performing better for the individual regions. And the East MMI performs really well, but we didn't think it was necessary to break it down to have individual MMIs for each component region of the East. So I hope that answers your question.
Okay, Tom, can you, let's see if you can unmute yourself.
Yes, I can unmute myself. Okay, and thank you. I enjoyed the presentation, especially incorporating trait-based indices. That's interesting. What about, and this is a question probably for the whole group, doing this kind of work, going at even at a higher level, at a class distinction. So if you look at, differences between, chlorophytes, cyanobacteria, and diatoms, I know a lot of times you get big responses to that. And just, it seems like, a lot of times the diatom people aren't talking to the cyano people, aren't talking to the chlorophyte people, but something just a pigment analysis.
So are you saying that to combine and look at the other types of algae as well and see how they fare in these regional scales?
Well, see if you have a greater distance between metrics. If you looked at just the differences in say pigment concentrations representing the different larger algal classes. So somebody say some of your disturbed sites may have more cyanobacteria, and that may be more indicative. Again, more like being able to see the forest without getting confused by all the trees.
Right. Yeah, I mean, this is just purely, like I say, it's purely a diatom-based MMI. And I'm not aware if NRSA actually look at the other types of algae as well in their assessments. But it's, yeah, I can't speak for them. I don't know if they're online and would like to weigh in, but as far as I understand, they haven't been able to use any of the periphyton data in their national or regional assessments, but they can correct me if I'm wrong.
Okay, yeah, thank you. I just want to entertain that thought. I'll go off now. Thank you again.
Yeah, thank you for your question, Tom.
Thanks, Tom. And we've got another question in the chat. So Layla asks about sort of taxonomic changes that epithemia and Rofolodia are now transferred into the single genus epithemia. And since they've been combined, have you noticed a different N-fixer response for these two previous genera? That is, they had been perhaps not as much of a signal when they were smaller in number, and now they're combined as
So
N-fixers.
in the N-fixer calculations, they are combined anyway. So I don't think it would make any difference. So the epithemia and the rhopalodia are combined. So it's just, in this case, we would just call them something different and we would combine them. But in the actual calculations, the two genera are combined. So it shouldn't make a difference in the actual overall MMI scoring.
Okay.
Sorry, I wanted to ask because in a fossil core from Mount Kenya, I have some level where I had a lot of epithemia, thorax, and with a small number of Rhopalodia giba,
Right.
and others with more Rhopalodia giba and very few epithemia thorax. So I wanted to know if we can distinguish a difference between these two levels in terms of and fixer response. If,
Right.
I mean, you.
Yeah, I mean, for the purpose of this MMI and how it's developed, everything is at a very coarse scale. So we're not distinguishing between the two. We're just lumping it together into the N-fixer trait metric and running the calculations.
Okay, thank you.
Thanks for your question.
Thanks.
And Sylvia asks, related to Leila's question, when new diatom genera are described, how do you envision incorporating these new genera into the MMI?
And that's a good question because, of course, there will be new genera. And in actual fact, I did have to drop some rare genera from this analysis because it wasn't in Remy and Boucher's trait database. These were rare though, and again, I don't think it would affect the overall MMI performance. But I think moving forward, it would be good to speak to the likes of you, Sarah, and Sylvia, and the larger diatom community to say, all right, well, we've got these new genera, and what traits do we think they fall under? And to try and classify them as best as we can. But it's possible that they might be rare because if they're newly described, perhaps they occur rare in abundance, so it again wouldn't affect the overall results.
I have a question. So you spoke a little bit about how the analyses would proceed. So do you envision that this approach would not change the way people do their analyses in the lab? The only change is in the way the data are analyzed.
So that's correct. It might be hard to change the analysis practices, although I believe that you are trying to change the practices and incorporating vouchers and making it more consistent in terms of resources amongst analysts and laboratories. But I think that these major analysis practices and the challenges that are met with those are definitely more related to issues with species level identification than genus level. And so I don't think it would be so necessary to change the analysis practices. But I mean, obviously, if you're improving them, that's great. That can only help the genus level identification.
But if that's true, if you don't need to have this expense, then why bother? Then why not change the analysis so you
Right.
have, you even just say diatoms with stalks or diatoms in tubes, and not continue to have the cost. I'm just kind of following out, the rationale that you're presenting for doing this approach.
Yeah, I mean, there are certain articles, is it Marina Potapova and Charles, that believe that for a more precise ecoregional assessment, that perhaps species-based analysis is important. There are researchers that advocate the use of species-based approaches for various reasons. And so if it's, if people still want to use the species-based approaches for whatever reason, then, I cannot argue with that. And I'm not trying to compete with that either. And perhaps you know more about this, Sarah, of other diatom researchers that have reason to use species-based approaches.
Yeah, actually, and if people want to hear alternative, November 16th, I believe it is, Nick Schulte will be presenting an alternate MMI that is based on modeling out natural variability and resulting application. So if people want to hear a different approach in using species levels ID, join the Web Academy in a couple of weeks. And Ryan has a question.
It's actually not a question. I just wanted to kind of add on to a little bit of what Luisa said. I think, what's important is, what Luisa's doing is trying to make use of data that hasn't been able to be used, in the way that we'd like to until now. And so I see the work that you guys are doing is really sort of taking it into, a way that really might be able to get diagnostic, because you're at a resolution of species that can be really important. But these data, we have years and, thousands of samples that we haven't really been able to take advantage of. And one way to do that would be to accept that we're going to have to use maybe genus-level resolution data for those. And she's showing that, at least at that resolution, we're getting MMIs that are as sensitive as some of the others that we've created in the past. And we can carry that forward and continue that, but then I think the work that you guys are doing are really taking it into another level that might be really diagnostic in the future. Right? So I think, I think what she's showing is that it's effective at these sort of coarse assessments of whether a stream is in good or poor condition, but it may not be totally diagnostic of where I think you guys might be able to take it.
Thank you, Ryan.
And I think that's something that we could also test as well, and how individual metrics respond to particular stressors. How diagnostic are these MMIs? So for example, when I did that analysis ID check, where I ran the random forest to check for analyst bias, and I ran with predictors for AnalystID and NRSA environmental variables as the predictors, and the response variable was each metric included in the MMI. I actually found that nitrate and potassium were top predictors for the N-Fixer trait in the Plains MMI. And for the East MMI, I found that conductivity and sulfate were the top predictors associated with the tube living metric, possibly responding to mining impacts in the East region. So it's possible that these MMIs can provide some level of diagnosis of what is impacting these waters.
Okay, some
Sarah?
more questions here. Yeah.
Yeah, this is Steve Paulson. I can't figure out how to raise my hand. I apologize. So
Okay.
when there's room, let me know and I'll.
Okay. Let me. Well, go ahead, Steve. Since you're on.
Since I butted in. Sorry about that. I just kind of a comment on this last round is I think it's a real mistake for us to edge toward pitting kind of genus level, trait level indicators versus species level indicators. I think the monitoring and assessment community has enough struggle getting the resources it needs to do its job that if we pit those different approaches against one another, we all lose. I think right now, if as Luisa's been demonstrating, we get valuable information in an assessment world out of the genus level and traits, then we ought to use that. There are going to be some groups that can never afford to go to species level. I think at the same time, we ought to continue investing in improving the consistency and the taxonomy as you've devoted your career to. I think that's really important for not only the ecology, but use of diatoms and algae. So I think we ought to look at this as a win for both groups when we get new approaches that are useful, in addition to the point, you know, Ryan and Luisa made about this opens up access to data where we don't have the benefit of the consistency that you and others have been building towards. So just some added thoughts about that.
Yeah, thank you. Some more questions in the chat. Sylvia asks, we wanted to look at specific stressors like nutrients affecting diatoms. Could we do additional analyses using this trait-based MMI?
I think that's the next paper, or one of the next papers. Yes, I would really like to explore more relationships with particular stressors, including nutrients, total phosphorus, for example. And it was a major issue across the United States. So yeah, that's definitely future work there that I think would be extremely valuable.
Okay, and Chad asks, the original intent of the Diatom guilds was to describe the shift from low profile to motile and high profile guilds with nutrient enrichment. Are you seeing a similar trend across scales in these MMIs with enrichment?
I cannot answer that right now because I haven't looked sort of deeper into the data sets and deeper into the actual environmental variables yet. So I can only say that I found that the high profile guild was more common in least disturbed sites versus most disturbed sites, and tube living was again in more least disturbed than most disturbed sites. But actually looking at shifts in trait composition, I wouldn't be able to answer that yet. I haven't looked into that, but that's a good question.
Well, maybe this is the next opportunity, as Cynthia asks or comments that I have around 60 Texas stream diatom community samples collected and analyzed over the past 15 years. If you're interested in looking at these, I'd be glad to send you the data. I would love trying to apply the Plains index to our samples. Most of these were from woody debris and identified by a single analyst.
Yeah, well, thank you for that opportunity. I would be very interested to look at your data set, and my email address is at the end of those slides. I don't know if you caught that, but perhaps I could get your email address and we can communicate afterwards.
She's got it in the chat.
Great,
here.
okay, thank you.
Let me see if I can copy that. And then David Burge asks, I may have missed it, but did you consider nitrogen to phosphorus ratios when trying to understand N-fixer distributions?
No, David, again, I didn't look into the details of specifics in the environmental variables. I only looked at environmental variables when I was just checking for analyst bias. So again, yeah, I haven't looked at that, but that could be something worth looking into.
Okay.
These are all very good ideas.
All right. See, is there anyone else who'd like to bring up a question or a comment? Okay, well, if not, please join me in thanking Luisa for a really informative approach to be able to use genus level characterization in MMIs. And thank you, Luisa.
Oh, and thank you for this opportunity. Appreciate it.